Hello everyone and welcome to this section. In this section we're going to locate a truck within an image, okay? But instead of doing it manually, we're going to use what we call it template matching, which is simply, again, I'm going to go within my image, okay, which is my original image that I'm looking for a truck within it. I'm going to use an image of a truck, okay, which is kind of the template that I have. And I'm kind of asking OpenCV to go in there and try to look, okay, where is that template? Where can I find it within my image? Okay, that's pretty much the idea. I have my image and I have my template, which is kind of, you know, like a picture of a truck, and I'm asking OpenCV to kind of draw a rectangle around the truck that's found in the original image. Okay, so what I'm going to use cv2.match template and cv2 min-max location to actually locate my truck. Okay, all right. Let's see how can we do this. Simply put, we're going to use cv2.match template. I'm going to provide it with the original image. I'm going to provide it with the template, okay? And we're going to do kind of, you know, in simple form, we're going to do kind of convolution. We're going to take the template, okay, and kind of mask it or just pass it by the image and see if it matches or not in a very simple form. We're just going to scan the entire image kind of in a 2D convolution form, okay? All right, and then the outcome or the return of this image, we're going to be imaged like this, which kind of the matching results, okay, indicating kind of, you know, different numbers within the image, and the number which is the maximum number as shown here, which is the most bright number. This actually location within the image indicates the top left corner of that truck or of that match that has been fired in a way. Okay, which when I say fire, that means, you know, I've been looking within the template in the image, and then once I found it, I'm just gonna take that top left corner here. I'm gonna set it to, let's say, 255, which kind of, you know, like one very bright color per se. Okay, then once I know that point, that's good. That means I know the dimensions of my truck. Right, at least I know the top left corner of my image. If I know the dimensions of my template, then I can locate the bottom right point using cv2.rectangle to draw the exact same rectangle as we've done before manually in a way. Okay, all right. So how can we actually perform that? Again, I'm not going to dig into the mathematics of the template matching or just kind of an object detection, but the whole idea is we're going to do kind of, you know, like perform correlation. Okay, so I'm going to take my image, all right, and take my template and kind of perform correlation within the image and the actual original image until I actually find my template or my location of my template. This is kind of the equation that's being implemented. Okay, there's a function kind of slides through the image I, compare it with the template T, and generate the results R. And then what we're going to do is do kind of a summation is done over that template and over the image patch. And we're going to come up with kind of, you know, this mathematics. Again, I don't want to dig into the details of what's happening in the background. We're just going to use it from a practical, applied way. All that happening, you know, kind of a magic for us using cv2.match template. And then if you guys want to read more about it, you can just check the OpenCV documentation, or you can check, there's still different paper that actually indicates how can you perform template matching in a, you know, from a very academic point of view. All right. Okay. So the question is, what are the challenges of this technique? Obviously, the first challenge is we have a lot of object variations. So let's assume that I'm, for example, driving my, you know, kind of self-driving car, and I loaded one image of a truck, which is, let's say, this image, okay, as kind of a template. And I'm asking, you know, the algorithm to do like kind of, whenever I take an image from a camera, from my self-driving vehicle, just gonna compare it to my template. The problem is there are so many different templates. There are so many different like trucks. You know, I can't just take one image that indicates the trucks. There are different colors of the trucks. There are different sizes of trucks. There are so many different variations. So template matching is very challenging, it's very challenged in this way. Okay. The other problem is orientations. What if, for example, my images or like the orientation is different? What if I'm like, for example, looking at the image, or looking at the truck, the exact same truck, exact same thing, but the problem is I'm looking at it from a different perspective. To have different perspective transfer, I need to perform perspective transform. All the template matching technique will gonna fail. Okay. What if I have different sizes? What if the vehicle or the truck is, for example, at a far distance away? Okay, so my template, I have my template here. This template, which is I had here, it's actually taken exactly with the exact same size as my original image, okay, which is obviously not the case. If that truck is a little bit closer, it will appear bigger within the image, right? Or within the camera image, which is a little bit challenging as well. All these are kind of challenges to my object detection or template matching. And that's why these are kind of very challenging to just use or rely only on template matching, because it will, kind of fail miserably, okay? All right. So again, orientation is one of the challenges. Image sizing and scale, again, is a challenge. Driving conditions. What if, for example, there's weather condition, brightness, contrast, and as well, obviously, perspective will challenge the technique if you're looking at a truck from a different perspective, as we covered before when we covered perspective transform. All right, and that's why, obviously, we're going to see how can we perform template matching first in a Python environment, and then afterwards, we're going to see how can we go beyond this to maybe check for colors, for example, and then go beyond that, look for edges, and then go further, look for corners, and then look way further to look for what we call it hog features, or what we call it histogram of oriented gradients, which is a very powerful technique that can be used to extract features no matter what the color is, no matter what the orientation is, and so on and so forth. All right, I hope you guys enjoyed that section, and see you in the next section.